Welcome to the next session, my dear friends. In the previous session, we are discussing the problems of the solid waste management. So we are left with only one problem. So let us complete that in this session. So the next problem, GATE 2019, 2 marks. So raw municipal solid waste collected from a city contains 70% decomposable material that can be converted to methane. The water content of the decomposable material is 35%. An elemental analysis of the decomposable material yields the following mass percentage. Carbon is to hydrogen is to oxygen is to nitrogen is to others is equal to 44 is to 6 is to 43 is to 0.8 is to 6.2. The methane production of the decomposable material is governed by the following stoichiometric relation. Given atomic masses, relation was given and atomic masses were given. The mass of the methane produced in grams. Okay. So this is the question. So let us extract the data given. So what is the given data? What is the given data? A raw municipal solid waste, okay, decomposable proportion in raw waste is 70%. Is 70% and moisture content is 35%. Okay, and the relationship between the different proportions, carbon, (44, 6, 43), (0.8) and 6.2. So equation was given CaHb Nd MCH4 plus SCO2 DNH3. SCO2 plus DNH3. So this is the equation given. Okay, so from this equation and from these values we need to extract the methane production. Okay, so first of all, to find this out we need to determine this N, M, S and D. So importantly M is needed. Rest of the things is not needed because we need CH4 production only. Okay, we need methane production. What is the methane? Mass of methane produced. Mass of methane produced in grams. In grams. So this is our question. So we need to determine the M value. It is a very simple question actually because we know the proportions here. We know the proportions in 100%. In 100% of these compounds. So this is the proportion of C 44. This is the proportion of H 6. This is the proportion of O, that is 43. And this is the proportion of N, and this is the proportion of others. Okay, so if you are taking 1 mole of it, that means 100%, a unit of this compound, then A will be how much? 44, B will be 6, C will be 43 and D will be 0.8, like that. Now, so let us first balance assume that this is a balanced equation. So in a balanced equation, the amount of reactants should be equal to the amount of products. Okay, the concentration in the reactants should be equal to concentration in the products. So here we are having how many carbons? A carbons are there. Okay, A carbons are there. Let us assume this A is 44 and D is 0.8 for 1 mole of gas, for 1 mole of solid waste. Okay, now A is 44, so I can write this as C44 H6 O43 N 0.8. Okay, so how many carbons are here? 44. On the left hand side it is 44. On the right hand side, how many carbons are there? Here M carbons are there, here S carbons are there. So M plus S is equal to 44. M plus S is equal to 44. Again come here, how many oxygens are here? Hydrogens. 6 hydrogens here, 2 into N hydrogens here. So on the left hand side, how many? On the left hand side 6 plus 2N on the left hand side. On the right hand side 4M plus 3D. Okay, see D we already know, this is D. This is D. So the same D given there. So 3D. So 3 into D, that is how much? 3 into 0.8, that is 2.4. That is 2.4. Okay. So now 4M, I will bring all these things on one side. 4M minus 2N is equal to 6 minus 2.4, that is 3.6. So this is equation number 1. This is equation number 2. So let us write the equation number 3 also for oxygen. How many oxygens are here? 43 plus N into O, that is NOs. So 43 plus N is the number of oxygens in the left hand side. So on the right hand side it is 2S. Simply it is 2S. That means 2S minus N is equal to 43. 2S minus N is equal to 43. So we are having 3 reactions. M plus S is equal to 44. M plus S is equal to 44. 4M minus 2N is 3.6 and 2S minus N is 43. So solving these 3 reactions, we are having 3 unknowns M, S and N. So we are having 3 equations. So we can find all these 3 unknowns. So by using these 3 equations, we can find the unknown M. So if you solve these equations, we will get the value of M. We will get the value of M as 11.7. It will be 11.7. M value we will get it as 11.7. So what is the molecular weight of this now? What is the molecular weight of this? So for this molecular weight, how much methane is coming? The methane which is coming is 11.7. So now the equations part is over. So we have found the amount of methane that is being produced. Now it is in moles. We want it in grams. So let us find how much grams are coming now. So here, what is the molecular weight of the reactant first? So molecular weight of weight of reactant. "44 carbons weight is 12. 44 12 6 into 1 plus 43 into 16 plus 0.8 into 14. If you do this, we will get the weight of the molecular weight of the reactant in grams for 1 mole, that is 1233.2, that is 1233.2 gram per mole. Okay, so this is the molecular weight of this matter in gram per mole. So this is the molecular weight of the matter in gram per mole. Now, so for this much 1233.2 grams destruction of the solid waste is evolving how much methane? So this much of methane. Well, let us find what is the molecular weight of methane produced. Molecular weight of methane produced. Molecular weight of methane produced is 11.7 carbons, that is 12 plus 11.7 into 4 hydrogens. Each hydrogen's weight is 1 gram. So the methane produced is 187.2. 187 gram per mole. Okay, so now for 1233.2 gram destruction we are getting 187.2 gram. For 1233.2 gram we are getting 187.2 gram. That means go back to our water supply engineering concepts in alum. So how we have found? Here for 33.2 parts of C44 produces 187.2 parts of methane. So one part C44 H6 O43 and 0.8 produces 187.2 by okay. So 1 kg of C44 H6O43 and 0.8, that is nothing but the municipal solid waste, produces how many kgs of this is 0.1518. This is so he has asked us to find this in grams, so multiply it with 1000, so that means 151.8 gram. 151. So this is the final value of the answer. This is the amount of methane that is produced for 1 kg destruction of the municipal solid waste. For 1 kg destruction of the municipal solid waste. So this is the last question of municipal solid waste, that is also completed. So we are entering into the last topic of our environmental engineering, that is air pollution and noise pollution. So completely is a theoretical topic. So only one or two concepts are there from which we can expect a problem. So rest of the part is completely theoretical, and these chapters are very lengthy actually, very huge syllabus. That means very huge portion is there to cover. But as far as GATE is concerned, some concepts are important which are frequently asked. So those concepts, and in the GATE point of view, we will discuss this topic. So this topic has no end actually. Air pollution, noise pollution, it's a very bulky, you can discuss any much, because this is a disciple in your post-graduation. So there is some disciples also on completely dealing with this pollution. Air pollution. What is meant by air pollution? So pollution is nothing but any unrequired matter which is harmful for the survival of human or any other living being also. That is nothing but pollutant. So pollutant means which causes harm to the living beings. That is nothing but pollutant. See, so the pollution, we see this term recently. We are learning this for the last 1 decade. From the last 1 decade, we are having some knowledge of this pollution and all. And we are researching how this is happening, why this is happening, and all these things we are seeing. So, if you look at the long back, so the pollution is there in the environment because of natural reasons, from the primitive stages, that is very long back also. You may think that this pollution is due to the man-made activities and all. But natural phenomena, some kind of natural phenomena are also causing pollution from the beginning of this, after this formation of the earth, and after the environment is formation of environment. So from that stage also, very primitive stages also, pollution is there. Like volcanic eruptions, okay, they causes lot smoke, okay, that is again a pollution in the environment. And some kind of natural disasters, that also create some kind of pollution inside the air. So there are many kind of natural contaminants which enter out of the natural phenomena. But parallelly, so after this industrial revolutions and all, so man is also contributing a lot to pollute the environment. So we are also sources. So those are called anthropogenic. So the threat or the pollution that is entering from the man-made mistakes, that is called anthropogenic pollution. So one pollution contributor is nature itself, other pollution contributor is man. So these two are the important contributors of pollution in the environment. Okay, so that is why this pollution is entering into the air. So if it enters, then we as engineers has to know how to control it also. So we need to try our best to control the environmental pollution such that it does not cause any harm to the human beings. So that is again a task which we need to perform. So we need to know, so what is the pollutant, And what is the concentration of that pollutant inside the air or environment, whether it is within the limits or it is exceeding the limits. If it exceeds the limit, then what are the effects of that pollutant on the human body or else any other living beings, and how can we prevent it? This is nothing but a full package of air pollution. So this is nothing but air pollution's engineering perspective. So we need to know what are the pollutants first. So what are the pollutants? Natural, anthropogenic. And again here another classification: primary, secondary. That means primary means any compound is a pollutant on it with its birth, with its origin. It is called primary pollutant. Some compounds are not pollutants by origin, but after it reacts with some other compound with the other primary pollutant, then it will become a pollution. Are you getting my point? So I will explain you what are the different kinds of primary pollutants, what are the different secondary pollutants, because there are many number of primary pollutants, there are many number of secondary pollutants. We cannot memorize all of them. But what are the primary pollutants which are so critical and also high in concentration in the environment, which are causing problems contemporarily to the human beings? That is those primary pollutants, and corresponding those secondary pollutants which are we look them day to day basis and which are very much a threat to the living beings. All those things, important primary, important secondary pollutants, we will discuss. And then how to find the concentration of it. So whenever we see the water supply engineering, wastewater engineering, what we have did first, what are the different physical parameters, chemical parameters, and every time we use a word limit. So that limit we represent it in ppm, but ppm works for liquids, but it does not work for air, gases. So we need to have a different methodology to find the concentration of the pollutant. So concentration of the pollutant, once you know whether it within the limit or not, it exceeding the limit, that we can understand. If it exceeds the limit, how to remove it, control it. Those are the things we will discuss. Okay, that is important for GATE. Okay, first of all, so what is the pollution? I have already told you. So sources of pollution. First is sources. Sources of pollution. So basic source is nature. Okay, so classification based on the origin. So there are many kinds of classifications based on the origin. Natural and anthropogenic. Anthropogenic. So natural means, I told you already different kinds of examples. So forest fires, dust storms, volcanic eruptions, so any natural disasters. So etc. So these are all comes under natural contributors of the air pollution. Okay, so anthropogenic means this is man-made. There are many man-made, we all know. Industries, prime and foremost is industries, automobiles, etc. Okay. So this is one kind of origin by origin classification based on the movement of the source. Okay. So based on the movement, that means based on the position, of source, stationary and mobile. So stationary means it is standing at a place and polluting the environment at that location only. But mobile sources, they pollute so wherever they go. So this pollution is dispersal. So we cannot calculate this pollution based on the location. We calculate the pollution based on the mobile source. What is the source, how much it is emitting. So example is an automobile. Automobiles are example of mobile category of pollution contributors, and stationary source is an industry where you will find the pollution at a same location again and again. So this is based on position. Based on spatial distribution, point source and dispersed or aerial. Aerial source. Aerial source. So point source means a single industry, if it is there, that is a point source. If a group of industries are there. So if you look at the recent times, we create a socio-economic zone, cells. So in that cells, it may be IT cells, industrial cells. So we will be having all the industries at a location, so that we can have a pollutant completely concentrated at that location only, so which we keep far away from the residential areas. So likewise, industrial regions, industrial park, like that. So these are called aerial sources. So only one industry is there, then those kind of sources are called point sources. Okay, those kind of sources are called point sources. So these are the classification of air pollutants. Okay, sources based on the sources, and classification of the air pollutants. Classification of air pollutants. Classification of air pollutants. So basic classification is primary pollutant and secondary pollutant. Okay, there are two basic classifications, that is so the primary pollutant, the pollutant by its origin, it is pollutant. Examples are, the major example is particulates or aerosols. aerosols, very very important pollutant these days. Okay, so next is CO, carbon monoxide, carbon dioxide, and also NO2, NOx, SOx, sodium oxides, and nitrogen oxides. So these are all different kinds of primary pollutants. These are all different kinds of primary pollutants. And secondary pollutants, there are different kinds of secondary pollutants also. The secondary pollutants, major secondary pollutants, they are coming out of this NOx. So majority of the secondary pollutants will come out of this nitrates, nitrous oxides, nitrogen oxide, nitrous oxide, anything. There are different kinds of this nitrogen compounds are there. All those are the contributors of the secondary contaminants or secondary air pollution. The secondary pollutants, examples: ozone, formaldehyde, pan, so this pan is also a pollutant which is coming out of the nitrogen, NOx. These are all photochemical oxidants. That means when these NOx compounds are present in the nature, so they react with the other compounds because of the natural sunlight, that is photochemical, in the presence of photons, that is which are emitting by the sun. Okay, so the sunlight energy will be taken as the energy source, and using that energy source, this NOx will react with other chemicals present in the nature, that is photochemical reactants, and with the help of the oxygen present with the nitrogen. So photochemical oxidation creates the photochemical oxidation of these nitrogenous compounds will cause different kinds of pollutants such as pan, peroxyacetyl nitrate, so this is one, and PBN. So next is PBN, peroxybenzoyl. And PPN, peroxypropanoil. So all these three are photochemical oxidants. So these are all photochemical oxidants. Okay, so that is why majority of the secondary pollutants are caused by this nitrogen compounds, and also smog also comes due to photochemical reaction. So photochemical smog, so smog is the combination of smoke plus fog. Smoke is one pollutant and fog is another pollutant. So combination of two pollutants. See, secondary pollutant may come out of a pollutant plus non-pollutant, or it may come out of two pollutants again. So anyways we call it a secondary pollutant. So pollutant, smoke is one pollutant, fog is one pollutant. So smoke plus fog, that is smog, that is again a secondary pollutant. Pollutant and non-pollutant, that is again also secondary pollutant. Okay. So these are all different kinds of secondary pollutants. These are all the different kinds of secondary pollutants. So from these, generally primary pollutants and secondary pollutants, we need to remember these examples, because in examination they will give you some options and they will ask you whether which of the following are primary pollutants, which of the following are secondary pollutants. Likewise they may ask you. So that is why, so remember the primary pollutants, what are the primary pollutant examples and what are the secondary pollutant examples. In primary pollutant we can add some more examples also. So halogen compounds. So in primary pollutants we can add some more, that is halogen compounds, halogen compounds means what? Fluorine, bromine, chlorine. So these are all halogens. Okay. So we learned this halogen term in our chlorine compounds. Chlorine, chlorination, disinfection there. So halogen group compounds are good disinfectants, as well as if they are present inside the air, that is again harmful for us. Okay. So directly we will take this halogen group chemical from our nasal respiration. So then they are very active chemicals if they enter into our human body. So they will do unnecessary reactions inside our human body which are very harmful. Okay. So that is why halogen group compounds are also considered as primary pollutants, and organic compounds are also considered as, so which are ready, BOD, we can say this as a BOD. Organic compound means biodegradable or biochemical oxygen demand if they are present, that is nothing but organic matter or organic compound. They are also considered as primary pollutants. And radioactive metals, radioactive chemicals, so they are all considered as primary pollutants. So these are the different kinds of primary pollutants and these are the different kinds of secondary pollutants. Okay. So now let us go to the next concept, that is, see here again we can classify in the pollutants, we can classify them organic and inorganic. Organic means where we are finding the carbons. Okay. So these hydrocarbons, they are considered as organic pollutants. Okay. So these are considered as inorganic pollutants. These are all inorganic pollutants. See, organic and inorganic, the classification can be simply made. Inorganic, organic means where there is a long chain reactions, or we can say which we create out of destructive distillation process. Generally petroleum products, so all those comes under these kind of hydrocarbons where there is a chain reactions. Even the admixtures which we use in concrete, they are also hydrocarbons. Naphthalene, okay, polycarboxyl ether. So all these things are the hydrocarbons only. So all are coming from the petroleum destructive distillation during the destructive distillation of the crude oil at different stages, we get different kinds of compounds. So those are nothing but hydrocarbons. Okay, so generally any material can be extracted out of destructive distillation or pyrolysis, or we can do it under incineration also. So after, if it is completely burned, combustion is completed, then inorganic compounds will come. Incomplete combustion, so which is having some kind of energy value, those are called organic compounds. Those are hydrocarbons. For one of the examples are hydrocarbons. So that we consider them as organic pollutants. Rest of the things we consider them as inorganic pollutants. Okay, which does not have any combustion value. They will be having some kind of energy value also. Okay, so now these are the different kinds of pollutants. So how to find the concentration of these pollutants? How to find the concentration of these pollutants? This concentration finding is very, very important. So from this air pollution, so the only problem that which we can expect is from this only. The only problem that which we can expect is from this concept only. So very simple concept, it is not that difficult. Simple chemistry, it depends on some knowledge of chemistry. So what we will do, it will take some time to explain this concept. So I will continue this in the next session. Okay, thank you so much.